Right. Now in this video, I'm going to teach you how to perform normality test. Right. Normality test. Now here, first of all, you need to know the reason for performing normality test. The main reason for performing normality test is to see whether the distribution of any variable, right? Distribution of any variable is nearly normally distributed. It doesn't need to be a perfect normal distribution, right? Because we cannot expect a distribution to be a perfect normal distribution. You know that when it comes to perfect normal distribution, curve mean should be equal to median should be equal to mode. So mean, median, mode, all three measures should be same. But it is not practical. Practically, it doesn't happen, right? So here, what we are expecting is that the normal distribution, sorry, the distribution should be a nearly normally distributed, approximately normally distributed. So how to measure this, right? Right. Now here, I have taken a database from a Google form, right? Now in this data set, this students database. Now the gender of students, right? Gender of students is given, and the marks for the statistics subjects is given, right? So likewise, different types of variables are there, right? So I'm going to measure, I'm going to see whether the variable marks is normally distributed, approximately normally distributed or not, right? So how to check this? Now remember, when you're going to measure this, when you're going to see whether distribution of any variable is approximately normal distributed or not, you need to see three criteria, right? These are those criteria. For a distribution to be nearly normal distributed, the following must be met. First one, skewness and kurtosis Z value should be somewhere in the span of minus 1.96 to 1 plus 1.96. I'll talk about this later, right? The second one, the Shapiro-Wills test P value should be above 0.05. And third one, the last one, histograms, normal QQ plots, and box plots should visually indicate that data are approximately normally distributed, right? So we'll check one by one. We'll go to the SPSS window and go to analyze and descriptive statistics, then explore, right? Now here you need to select some independent variables. Now here the dependent variable is marks, right? Dependent variable is the variable that of which you are going to measure this normality, right? I'll select marks, right? Then now the marks can be differed with the gender, no? So I'll select gender as the factor, right? Now factor is like independent variable, okay? Right. Then we'll go to statistics, no issues. Then plots. Now here you need to tick this box. Normality plots with test. Then histograms. No need to tick this one, stem and leaf. Then factor level together. Right. This is okay. You continue. Options. No changes required. Yeah, that's it. We can give okay now. Right. Now see. Now here, go to skewness. Go to skewness. go to skewness. See, in this table, the second table, marks, first one. Now this is for the marks of male students, and the second one for the marks of female students, right? Right. Now you know, for a distribution to be normal, the skewness should be 0, right? If the skewness is 0, the distribution is normal. If the skewness is the positive value, then the distribution is a positively skewed distribution. If the skewness is a negative value, it is a negatively skewed distribution. But now, for a distribution to be normal, the skewness should be 0, but we cannot expect a distribution to be a perfect normal distribution curve. So we cannot expect that the skewness to be 0, right? But it can be around 0, right? It should be around 0. Now, see the requirements again. Skewness and kurtosis Z value should be somewhere in the span of minus 1.96 to plus 1.96. Now here, I'll open an Excel sheet. Right. First one, marks of male students. Then marks of female students. Right. Then skewness Z value. Then kurtosis. Kurtosis Z value. Kurtosis Z value. Right. Now the skewness has been computed for the marks of male students as well as marks for female students, and kurtosis has been generated for marks for male students and marks for female students, right? So skewness Z value is somewhat different from skewness, and kurtosis Z value is somewhat different from kurtosis, right? Now, how to find skewness Z value? It can be taken in this way. Now, skewness measure is minus 1.619. Now, when it comes to male students, the skewness is minus 1.619, and the standard error, the second column, see, standard error is 0.512, right? So skewness is value is skewness measure this minus 1.619 divided by the standard error, which is 0.512. So let's calculate skewness is value. Marks for male students, skewness is minus 1.619, minus 1.619, minus 1.619 divided by is standard error 0.512, 0.512, 0.512, right? 0.512. Then the kurtosis Z value for male students, right? In the same way, take the kurtosis value 4.887, 4.887 divided by standard error 0.992, 0.992, 0.992, right? 0.992, right? Then marks for female students, right? Marks for female students, the second part of the table, skewness value is minus 0.642, minus 0.642 over the standard error 0.501, 0.501. This one 0.501, 0.501. Then the kudos is Z value, right? Minus 0.020 minus 0.020 over 0.972, which is the standard error. Right. Now these are the Z values. Now go to the requirement again. Skewness and kurtosis Z value should be somewhere in the span of minus 1.96 to plus 1.96. Right. It should be in between minus 1.96 to plus 1.96. Now when it comes to male students, the distribution of the marks of male students, right? Distribution of the marks of male students. The skewness Z value is minus 3.16. It is not in between minus 1.96 and plus 1.96. So it is out of the criteria, right? It doesn't meet the criterion. Okay. And the kudos is also way above 1.96. So it doesn't meet the criterion again, right? So the criterion 1 has not been met by the first one, marks of male students, right? Not met, right? Second one, marks of female students. Skewness Z value minus 1.28. It is in between minus 1.96 and plus 1.96. No, so it is okay. Kudos is Z value minus 0.02. It is also in between minus 1.96 and plus 1.96. So no issues, no. So here criterion is met. Okay. We'll go to the second criterion. The Shapiro-Wilk test p value should be above 0.05. We'll go to the third table, test of normality, and take the second part of the table, Shapiro-Wilk test. This one, Shapiro-Wilk test. Go to the significance, the third column, the last column, right? Let's take first marks of male students. First row, marks of male students. Male students. Significant value is 0.007. So it is way below 0.05. It is way below 0.05, right? So it indicates that, right? It is way below 0.05. According to the criterion, that value should be above 0.05, right? For the distribution to be a nearly normally distributed one. So due to that, we can say that it is not normally distributed, right? Now when it comes to second criterion, now first criterion is okay. Second criterion. According to the second criterion, right. According to the second criterion, marks of male students, right? Again not met, right? But here female students, that distribution, see, the value is 0.128, which is above 0.05, which is above 0.05. So it is met, no? Criterion is met. So uh, it should be a nearly normally distributed, approximately normally distributed, right? Right. Third criterion, the histograms and plots should indicate that the graphs, right, the distributions, right? The distributions are approximately normally distributed. Histograms and the other plots should visually indicate that data are approximately normally distributed. And we'll see the graphs. Marks of male students. Right. Now, according to the graph, it is unlikely to be a normal distributed one, no? Right. But here we can say like, right. And when it comes to this graph, normal QQ plots, right? It also now see, now it is if it is approximately normally distributed, uh, almost all the uh, points, almost all the points should be around this linear line, linear curve, right? Just skip this one, right? Right. But the thing is that with visual graphs, right? We cannot exactly say whether it is approximately normally distributed or not, because it depends on the way we see now. It depends on the way we see, right? So it is very subjective. So uh, try to take values and prove, right? So we better rely on first two criteria, right? We better rely on first two criteria. So the first one was skewness and kurtosis is rebellious. Those should be somewhere in the span of minus 1.96 to plus 1.96. The second one, Shapiro-Wilk test p-value should be above 0.05. Now, when it comes to those measures, right? Those criteria. Now see the results. Now, according to the results, we can say that marks for females, that distribution should be a nearly distributed, normally distributed one. Nearly normally distributed or approximately normally distributed. Why? The both criteria have been met. But when it comes to marks for male students, right? Both criteria have not been met. Both criteria have not been met. So with that, we can come to a conclusion that the marks of male students, that distribution is not an approximately normally distributed one, but the marks for female students, I should be a approximately normally distributed curve, right? Approximately normally distributed one. Okay. So when it comes to marks for male students, normality is not there. But when it comes to marks of female students, normality is there. Right? That should be the conclusion. So when you write in your research report, first talk about the first criterion, then you can talk about the second criterion, whether it is met or not. right? Whether it is met or not, right?